Maths with Sarah, a true lover of maths. I am back with one more video on inverse trigonometric functions. Let us continue the properties of inverse trigonometric functions. Next set of properties: tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, and tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. Here the condition is x into y must be less than 1. Here x into y must be greater than minus 1. Let us take tan inverse x as theta and tan inverse y as phi. Now we can write x as tan theta and y as tan phi. We have learned last year that tan a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. Isn't it? We have learned last year tan a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. So we can write tan theta plus phi as tan theta plus tan phi upon 1 minus tan theta tan phi. Now replace tan theta by x and tan phi by y. We get x plus y upon 1 minus xy. Now taking inverses on both sides, this is tan theta plus phi. Taking inverses on both sides, we get theta plus phi is equal to tan inverse x plus y upon 1 minus xy. What is theta? Tan inverse x. What is phi? Tan inverse y. So we get the final answer as tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Is it clear? Similarly, we can prove the next property: tan inverse x minus tan inverse y is equal to tan inverse x minus y upon 1 plus xy. Conditions are here. Here product of x and y must be greater than minus 1. Here product of x and y must be less than 1. Okay, now the last set of properties of inverse trigonometric functions, that is 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. That is also equal to 2 tan inverse x is also equal to cos inverse 1 minus x square upon 1 plus x square, and 2 tan inverse x is also equal to tan inverse 2x upon 1 minus x square. First we will prove, then we will apply. First one, 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. How to prove this? Let tan inverse x is equal to theta, then x is equal to tan theta. Then x is equal to tan theta. Take the right hand side. Sin inverse 2x upon 1 plus x square can be written as, in place of x, write tan theta. Sin inverse 2 tan theta upon 1 plus tan square theta. You have learned last year 2 tan theta upon 1 plus tan square is nothing but sin 2 theta. So we can write it as sin inverse sin 2 theta, that is equal to sin inverse times sin 2 theta is equal to 2 theta. What is theta? Tan inverse x. So 2 tan inverse x is equal to sin inverse 2x upon 1 plus x square. Similarly, we can prove the other two. Okay, now we will practice some questions related to the properties. First one, prove that 2 tan inverse half plus tan inverse 1 by 7 is tan inverse 31 by 70. Look at the question carefully. It is not tan inverse half, it is 2 tan inverse half. So first of all, use the property here. Then it will reduce to the form tan inverse x plus tan inverse y. So we will start the question. 2 tan inverse half plus tan inverse 1 by 7 can be written as, what is 2 tan inverse x? 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. So we can write it as tan inverse 2 into x is 1 by 2 tan inverse 2x upon 1 minus x square. 1 minus 1 by 2 the whole square plus tan inverse 1 by 7. Okay, that is equal to 2 and 2 will cancel. This is tan inverse 1 by 1 minus 1 by 4 plus tan inverse 1 by 7. 1 minus 1 by 4 is 3 by 4. So this becomes tan inverse 1 by 3 by 4, that is 4 by 3 plus tan inverse 1 by 7, that is equal to tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. Here also x into y is less than 1, isn't it? So we can apply the formula directly. Tan inverse x plus y upon 1 minus xy. Now take the LCM and solve it. It becomes tan inverse 7 4s are 28 plus 3 upon 7 3s are 21 upon 7 3s are 21. This is 21 minus 4. 21 and 21 will cancel out. We get the value as tan inverse 28 plus 3. What is 28 plus 3? 31 upon 21 minus 4. Tan inverse 28 plus 3 is 31 upon 21 minus 4 is 17. So we will get the answer as tan inverse 31 by 17. Very easy, not confused. This is not tan inverse x. This is 2 tan inverse x. So apply the property of 2 tan inverse x first. Now look at the second question. Again prove that 2 sin inverse 3 by 5 is equal to tan inverse 24 by 7. We don't know any property related to 2 sin inverse x. What we know is 2 tan inverse x. So convert sin inverse in terms of tan inverse. How can we do that? With the help of Pythagoras theorem. For that, let sin inverse 3 by 5 is equal to x. Then 3 by 5 is equal to sin x. Okay. Draw right triangle here. Draw right triangle here. This is 3 by 5. 3 by 5. So this side is equal to root over 5 square minus 3 square. Root over 5 square means 25. 25 minus root over 25 minus 9, that is root over 16, that is equal to 4. If you know Pythagorean triplet 3, 4, 5 is a Pythagorean triplet, then you can write the answer directly also. Means in place of, tan x is equal to 3 by 4. Means in place of sin inverse 3 by 5, we can write tan inverse 3 by 4. Tan sin inverse 3 by 5 is the same as tan inverse 3 by 4. Now we are able to solve the question. So 2 sin inverse 3 by 5 is equal to 2 tan inverse 3 by 4. 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square. Tan inverse 2x upon 1 minus x square. Solving this, we get tan inverse 2 and 4 cancel. 3 by 2 upon 1 minus 9 by 16. So what is the final answer? Tan inverse 3 by 2 upon 16 minus 9. What is 16 minus 9? 16 minus 9 upon 16. 16 minus 9 is 7. So we can rewrite it as tan inverse 3 by 2 into 16 upon 7. This will cancel 8. That is the final answer is tan inverse 24 upon 7. First thing you should remember is we have no property related to 2 sine inverse x. So convert sine inverse in terms of tan inverse. If you know the Pythagorean triplet, instead of writing all these steps, you can write the answer directly. Sine inverse 3 by 5 is the same as tan inverse 3 by 4. Then we can apply it directly using the property 2 tan inverse x. Hope it is clear to you. Okay, now look at the next question. Sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 77 by 36. Again same problem. We don't know any direct formula related to sine inverse x plus sine inverse y. So we will convert sine inverse in terms of tan inverse. Then we know how to solve this. First, sine inverse 8 by 17 as x. Then 8 by 17 is equal to sine x. Complete the right triangle. Sine means perpendicular by hypotenuse, 8, 17. So this side is equal to root over 17 square minus 8 square. That is nothing but 17 plus 8 into 17 minus 8. 17 plus 8 is 25, or 17 minus 8 is 9. So its square root is 5 into 3, that is equal to 15. So what about tan x? Tan x is equal to 8 by 15. Other one is sine inverse 3 by 5. We done it recently. That is equal to tan inverse 3 by 4. Isn't it? Sine inverse 3 by 5 is the same as tan inverse 3 by 4. Pythagorean triplet. This is also Pythagorean triplet. If you know the answer directly, then you can write it directly also. Now, sine inverse 8 by 17 plus sine inverse 3 by 5 can be written as tan inverse 8 by 15 plus tan inverse 3 by 4. This is the same as tan inverse x plus tan inverse y. Product is less than 1 also. So we can apply the formula. This is equal to tan inverse x plus y upon 1 minus 1 minus xy. Now taking the LCM we get tan inverse 15 fours are, right, either 15 fours are 60 or 15 into 4, leave it as it is. So numerator becomes 8 fours are 32 plus 15 threes are 45 upon 15 into 4. 15 fours are 60 minus 8 threes are 24. 15 denominator cancels out. Add the numerator, it becomes tan inverse 32 plus 45. 5 plus 2 7, 4 plus 3 7, 77 upon 60 minus 24 is 36. So we get the answer as tan inverse 77 upon 36. Only thing you have to remember is we have no direct formula related to sine inverse x plus sine inverse y. So convert it in terms of tan inverse x and tan inverse y. Now look at these two questions. Either we can do it like above or one more method is there. Because here the answer is in cos inverse. If we apply the formula tan inverse x plus tan inverse y, then the answer will be in tan. Then we have to convert it once again to get the answer. So it's a lengthy one. We can do it in that method too, but I am using one more method which is almost direct method. For that, cos inverse 4 by 5, take cos inverse 4 by 5 as x, then 4 by 5 is equal to cos x. Okay. Now we will write sin x. Sin x is equal to root over 1 minus cos square x, isn't it? So this is equal to 1 minus 4 by 5 the whole square, 16 by 5. On subtracting we will get root over 9 by 25, that is 3 by 5. Okay, sin x is 3 by 5. Similarly, cos inverse 12 by 13 as y, then 12 by 13 is equal to cos y. 12 by 13 is equal to cos y. Then sin y is equal to again root over 1 minus cos square y, that is 1 minus 12 by 13 the whole square. This is equal to root over 13 square minus 12 square upon 13 square. A square minus b square, a plus b, a minus b. 13 plus 12 is 25. Root over 25 is 5 by 13. We get sin y as 5 by 13. I hope all of you remember the identity cos a plus b. Cos a cos b minus sin a sin b. So we will use the identity cos x plus y, that is cos x cos y minus sin x sin y. Cos x cos y minus sin x sin y. What is cos x? 4 by 5. What is cos y? 12 by 13 minus what is sin x? 3 by 5, and what is sin y? That is 5 by 13. Denominator same, 15 into 3, 15 3s are 65, 12 4s are 48 minus 15, we get the answer as 33 by 65. That is cos x plus y is 33 by 65. That is x plus y is cos inverse 33 by 65. What is x? Cos inverse 4 by 5. What is y? Cos inverse 12 by 13. So we get the final answer as cos inverse 4 by 5 plus cos inverse 12 by 13 is equal to cos inverse 33 by 65. Now look at the next question. Cos inverse 12 by 13 plus sin inverse 3 by 5 is equal to sin inverse 56 by 65. The answer is in sin inverse. Okay, so we will use the identity sin a plus b. So we will start cos inverse 12 by 13 is equal to x, then 12 by 13 is equal to cos x. From that we will write sin x. Sin x is equal to root over 1 minus cos square x, that is root over 1 minus 12 by 13 the whole square, that is equal to 5 by 13. On solving we get the answer as 5 by 13. Next one, sin inverse 3 by 5 as y, then 3 by 5 is equal to sin y, therefore cos y is equal to root over 1 minus 3 by 5 the whole square, that is equal to 4 by 5. We get sin x and cos y. Since the answer is in sin, we use the formula sin x plus y. The pattern of sin is sin cos cos sin, so we can write it as sin x cos y plus cos x sin y. Now substitute the values. Sin x is equal to 5 by 13 and cos y. What is cos y? 4 by 5 plus what is cos x? Cos x is equal to 12 by 13 cos x, and sin y is 3 by 5. So 13 5s are 65. Numerator 5 4s are 20 plus 12 3s are 36. This is equal to 56 upon 65. This is sin x plus y. So we can write x plus y as sin inverse 56 upon 65. Now replace x by cos inverse 12 by 13 and y by sin inverse 3 by 5. We get the final answer. Since the answer is in sin and cos, the direct method or the easiest method is apply the identity of cos a plus b and sin a plus b. We can solve it using the other method also, using tan inverse. That is also right. For the last answer you have to convert it once again to tan inverse. Is it clear? Thank you for watching my video. Hope all of you are enjoying my classes. If you have any doubt regarding these questions, comment below. If you like my classes, like, share and subscribe it too. I will be back with more videos. Till then, bye.